Hi, the chances are you've probably registered for this course to get your accreditation to use pesticides as a part of your normal work. But before we go any further, we need to answer the question: do I need to use pesticides for this job? That is, we need to think about what the pesticides are, how we decide when to use them, and if we do, then how we can use them most effectively. These decisions can only be made after we collect good information about the pest we're trying to control, what pesticides are available for our job, the costs of using those pesticides compared to other ways of controlling that pest, or even for doing nothing, and conditions where we will be using the pesticide. During this introduction, we'll look at some of the features of pesticides to help set the scene for the rest of this course. Let's think about what are pesticides. Pesticides are chemicals that kill or interfere with the growth of pests, and pests are any living things that affect your farm production. There are many types of pesticides. For example, we use herbicides to control weeds, insecticides to control insects, fungicides to control fungi, and so on. These are all types of pesticides. On your screen you can see 3 examples of pesticides. Confidor is a fungicide and kills fungi. Clout is an insecticide used to kill lice, which are insects. And Roundup is a herbicide used to kill plants or weeds. These are all pesticides. Additionally, we can think about pesticides as being natural or synthetic. Natural pesticides are made from living things, and synthetic pesticides are artificially produced in laboratories. Both types, natural and synthetic, are used to control pests, and both have some risks associated with their use. For example, pyrethrum is a naturally occurring pesticide derived from plants, the pyrethrum daisy. However, its chemical label carries warnings and instructions on how to use it carefully, showing that it does have some risks associated with it. The question, should I use a pesticide, is one of the first things you should ask yourself when looking to control a pest. So when planning a pest control program, we need to consider not only how it will reduce pest numbers, but what impacts the program will have, particularly on our environment and also on our back pocket. For example, it's not wise to use a method that gives great pest control if it also wipes out other plants or animals. On the other hand, we don't want to ignore the benefits of pesticides through lack of information or understanding about them. With good knowledge and planning, pesticides can play a very important part in your pest control. We know that pesticides can be very economic to use. They can be integrated with other methods to give really good pest control. They can be used safely without harming the user, and they can be applied without harming the environment or other plants or animals. Having a closer look at pesticides, we can ask what goes into them. They normally have 3 main components. The active ingredient, which is actually the chemical responsible for killing the pests that you're setting out to control. They usually also have adjuvants, which are any chemicals that are added to help the pesticide perform better. And as an example, we sometimes have chemicals added that will help the pesticide spread and stick to leaves. And finally, there is also a carrier, which is responsible for carrying the pesticide, and it could be something as simple as water. These three added together usually make up the total of the pesticide. Having a quick look at how pesticides work, we can say that the active ingredient works by interfering with one or more processes inside the pest. We call this the mode of action of the pesticide. The mode of action refers to how the pesticide affects a pest, how the pesticide actually kills a pest. Pesticides that kill pests in the same way are grouped together in mode of action groups. We'll talk more about mode of action groups later, but for now just remember that pesticides in the same mode of action group all control pests in the same way. Pesticides are often sold in many different formulations. For example, they might be a liquid, a dust, a powder, an aerosol, or any other types of formulations. Which particular formulation is used depends on the type of the pesticide, how it will be applied, and where you're going to use it. For example, most broadacre crop pesticides or herbicides are liquids, and they're made that way so they will be suitable for mixing in a boom spray. Some pesticides are very selective. They kill specific pests. Other pesticides are non-selective, or they kill a broad range of pests. A good example is Roundup, which is a non-selective herbicide. It's used to kill many different types of weeds. And you can also kill your roses or your tomatoes with Roundup by mistake. We know that it kills an enormous range of plants. On the other hand, MCPA is a selective herbicide. It kills very specific types of weeds, in this case broadleaf weeds. The other thing we need to think about before we start using pesticides is what happens to them after I've applied them. So after we've applied pesticides, even after we've achieved good pest control, what then? Where does the pesticide go? Let's have a look at a herbicide that's been sprayed on crop weeds as an example. You can see that some of it evaporates. Some of it's broken down by sunlight. Some of it is washed away or down through the soil by leaching. Some of it's broken down by microbes in the soil or taken up by animal life in the soil, such as earthworms. Luckily, some of it at least is taken up by the weed that you're trying to control. Of course, it may also get onto plants that you weren't intending to hit. Pesticides vary greatly in how long they continue to do their job. Many do not persist for very long. They act on the target, in this case a weed, and then they're broken down into harmless substances very quickly. However, some are made to last for a lot longer time, and these are often called residual herbicides. The speed of pesticide breakdown depends on which chemicals are in the pesticide, how much pesticide has been used, how it's been distributed, and a lot of environmental conditions such as temperature, moisture, what types of microbes are present, etc.